Hey everyone, and welcome back to DemoHub Pod, exploring the cutting edge of tech AI and data powered by AI. Today we're diving into a topic that's fundamentally changing how we interact with information. Vector databases. Buckle up because this is going to be a wild ride.
Yeah, what's really cool about vector databases is they allow us to move beyond,
Yeah.
simple keyword searches. We're entering a world where we can search based on the actual meaning of data.
It's like being able to search for images by concept instead of just by tags. Imagine uploading a picture of let's say, a fluffy hamster,
Yeah.
and instantly getting back visually similar images, even if they're not labeled hamster. That's the power of vector databases and embedding.
Embeddings are essentially numerical representations of data. Think of it like a secret code that captures the essence of your data, whether it's text and image, audio, or even video.
So instead of manually tagging all those hamster pictures with attributes, we're using machine learning to create embeddings that represent those features automatically.
Right. That means we can compare images based on their deeper meaning and similarity, not just on simple keyword matches. It's a whole new level of search capability.
Okay, so we have these embeddings, these powerful representations of our data. But why do we need a special kind of database to handle them? Why can't we just use our good old-fashioned databases?
Well, traditional databases are great for structured data, information that fits neatly into rows and columns. But when it comes to these complex embeddings, which exist in what we call high-dimensional space, traditional databases struggle.
High-dimensional space. That sounds pretty complex. Can you break that down for us a little?
Okay, think of it this way. A spreadsheet with columns for name, age, and city is like a three-dimensional space. Each person's data is a point in that space. Embeddings often have hundreds or even thousands of dimensions, which is way beyond what traditional databases are designed to handle.
That makes sense. So vector databases come in to save the day because they're purpose-built to store, index, and search this kind of complex data.
Exactly. They use specialized algorithms, like approximate nearest neighbor search, or ANN, to quickly find similar vectors even across massive data sets.
But it's not just about storing the data. It's about being able to find the right information quickly and efficiently.
That's exactly right. And this speed and efficiency are crucial for AI applications where real-time analysis and responses are often required.
Now, for our tech-savvy listeners out there, what are some of the key features that make vector databases so powerful?
Well, one key feature is the indexing techniques they use. Techniques like inverted file, IVF, hierarchical navigable small world, HNSW, help organize those vectors for fast retrieval.
I imagine this is especially important as the size of the data set grows, right? You don't want searches to slow down just because you have more data.
Absolutely. Efficient indexing is crucial for scalability. And another neat feature is the concept of hybrid search. It allows us to combine vector search with traditional keyword search.
So it's like having the best of both worlds. You can search based on meaning and also use keywords for precise matches when you need them.
Precisely. And another advantage is that, unlike standalone vector indexes, vector databases can be updated in real time. As new data comes in, it can be incorporated immediately, keeping the information fresh and relevant.
And let's not forget about metadata.
Right. We can store additional structured information alongside our vectors, such as timestamps categories or user IDs, to further refine our searches and build richer applications.
Okay, so we've covered the basics of what vector databases are and how they work. But what about real-world applications? Where are we actually seeing these databases in action?
One of the most compelling use cases is in chatbots and virtual assistants. They use what's called Retrieval Augmented Generation, or RAG, to enhance the responses with real-time information pulled from a vector database.
So it's like having a chatbot that can actually understand the context of your question and provide a detailed, accurate answer, even if it wasn't specifically programmed to that information.
That's a great way to put it. For example, imagine you're asking your company's chatbot a question like, what is Pro?
Without a vector database, the chatbot might just give a very general answer about,
Yeah.
Pro being a premium subscription.
But with RAG and a vector database, it can pull up detailed information on what Pro specifically offers for that particular company, like enhanced security features, compliance benefits, and even pricing information.
That's incredibly powerful. And it highlights how vector databases are changing the game when it comes to building intelligent applications.
And that's just the tip of the iceberg. We're seeing vector databases being used in everything from recommendation engines to content creation tools. The possibilities are truly vast.
This is all incredibly fascinating. Stay tuned for part 2, where we'll delve even deeper into the world of vector databases and explore even more exciting use cases.
Welcome back to DemoHub Pod. It's great to have you back as we continue our deep dive into vector databases.
I'm excited to be back too. It feels like we've only just scratched the surface of what vector databases can do.
It's true, we've got a lot more ground to cover. Before we jump back into specific use cases, I think it's worth taking a moment to appreciate how far we've come. Not that long ago, working with this kind of unstructured data, like images and text, was a real challenge.
It's like we were trying to fit square pegs into round holes, forcing this complex data into rigid structures.
Exactly. But now with vector databases, we have these specialized tools that not only make it possible to work with this data, but they make it incredibly efficient.
It feels like we've unlocked a new level of data understanding. We're moving beyond just storing and retrieving information to actually comprehending its meaning and the relationships within it.
And that's what's fueling this explosion of innovation in AI. It's allowing us to build applications that were practically unimaginable just a few years ago.
Speaking of applications, our source material highlighted some really interesting use cases. I'm particularly intrigued by the idea of using vector databases for content creation.
Oh, that's a fascinating area. Imagine using a vector database to help you write music. You could feed it a few notes or a melody, and it could help you find similar musical phrases or patterns based on its understanding of the underlying structure of music.
It's like having an AI muse whispering creative inspiration in your ear. And what about using vector databases for automated writing? Is that science fiction, or is that happening now?
It's happening now. There are tools out there like Jasper and Copy.ai that use machine learning models and vector databases to generate high-quality text for everything from blog posts to marketing copy.
That's a game changer for content creators.
Yeah.
It frees them up to focus on the bigger picture, the strategy and creativity, while the AI handles some of the heavy lifting. But the potential goes way beyond just creating new content, doesn't it? I'm thinking about areas like scientific research or historical analysis.
You're absolutely right. Think about a historian trying to analyze a massive collection of historical documents. Instead of having to manually read through thousands of pages, they could use a vector database to identify documents with similar themes, writing styles, or even emotional tones.
There'd be a huge time saver and could lead to discoveries that might have been missed using traditional methods. And in scientific research, vector databases could be used to analyze huge data sets of genetic information or scientific literature, potentially accelerating the pace of breakthroughs.
It's incredible to think about the possibilities. It seems like there's almost no limit to the industries that could be transformed by this technology. But like with any powerful tool, I imagine there are potential downsides too.
That's a really important point. We need to be mindful of how this technology is being used and ensure it's not perpetuating harmful biases or being used in ways that could have negative consequences.
I completely agree. As developers and tech professionals, it's our responsibility to think critically about these issues and make sure we're building systems that are ethical and responsible.
So we've talked about the applications, but let's shift gears a bit and talk about the technical side. We touched on indexing and search algorithms earlier, but I'm curious about the role of hardware in vector database performance.
Hardware is a critical piece of the puzzle. Traditional CPUs, the brains of our computers, can sometimes struggle with the intense computational demands of vector similarity search.
It's like trying to run a marathon with ankle weights on.
That's a great analogy. That's why we're seeing a shift towards specialized hardware like GPUs, which are designed for parallel processing. They can handle these operations much more efficiently.
So it's like having a supercharged engine for your vector database.
Exactly. And this is where cloud computing plays a huge role. Cloud platforms like AWS Azure and Google Cloud offer access to powerful GPU instances that can handle even the most demanding vector database workloads.
That means even smaller organizations can now harness the power of vector databases without having to invest in expensive hardware.
Absolutely. Cloud computing is democratizing access to this incredible technology, which is really exciting. Our source material also mentioned a trend towards energy efficiency in the vector database space. What's driving that?
It's all about sustainability, which is becoming increasingly important in the tech world. The rise of ARM-based CPUs is a key factor. They're known for being very energy efficient, which is crucial as we deal with larger and more complex data sets.
So we're not only seeing performance improvements, but also a focus on reducing the environmental impact of this technology. I think that's a really positive trend. And as demand for vector database technology keeps growing, I think we can expect to see even more innovation in hardware. With new architectures and processors specifically designed for these kinds of workloads, it's a really dynamic and evolving field.
It sounds like we've covered a ton of ground in this part, but there's still more to explore. In part 3, we'll dive into some of the key trends and challenges shaping the future of vector databases. Don't miss it. Welcome back to DemoHub Pod for the final part of our deep dive into vector databases. It's been a fascinating journey so far.
It really has. We've explored the fundamentals of vector databases, seen some incredible real-world applications, and even touched on some of the challenges they present.
Now it's time to look ahead. What does the future hold for vector databases? What trends should tech professionals like you be paying attention to?
Well, one trend that's really caught my eye is the emergence of serverless vector databases.
Serverless. I've heard that term thrown around a lot lately, but I'm not sure I fully grasp it in the context of databases.
Sure, it's all about scalability and cost efficiency. Imagine a database that can dynamically scale its computing resources based on demand. You only pay for what you use, and you don't have to worry about managing any infrastructure.
That sounds like a dream come true for developers, especially for applications with unpredictable workloads.
Exactly. Serverless vector databases free you from the burden of infrastructure management, so you can focus on what really matters, building amazing AI-powered applications.
And this ties into another trend we've been discussing, the growing importance of cloud computing in the vector database space.
Right, cloud platforms are becoming the go-to choice for hosting and managing vector databases. They offer the scalability, flexibility, and on-demand resources that are essential for handling the demands of AI applications.
Not to mention the robust security measures that cloud providers have in place. That's a huge plus for anyone dealing with sensitive data.
Absolutely. And we're also seeing the rise of specialized cloud-based vector database services, like Pinecone and others that are making this technology more accessible than ever before.
It's incredible to see how the cloud is democratizing access to such powerful technology. Our research also mentioned advances in retrieval models. Can you shed some light on what those are and why they're so important?
Retrieval models are the algorithms that power the search process in a vector database. They're responsible for finding the most relevant vectors for a given query.
So essentially, they determine how effectively the database can understand and respond to our search requests.
Precisely. Improvements in retrieval models lead to more accurate and efficient searches, which is crucial for delivering a seamless user experience.
And it sounds like there's a lot of innovation happening in this area.
Absolutely. We're seeing new retrieval models like Seabird that are designed to better understand the context and relationships within data. This leads to more precise search results that are truly aligned with the user's intent.
It's amazing to see how this field is constantly evolving, driven by the incredible growth in AI applications. It seems like we're just at the beginning of what's possible with vector databases.
I couldn't agree more. As we demand more from our AI systems, the technology that powers them, like vector databases, needs to keep pace.
So for all our listeners out there who are working in tech, especially in areas related to AI, machine learning, or data science, understanding vector databases is no longer just a nice-to-have. It's a must-have.
Yeah, vector databases are quickly becoming a core component of the modern AI tech stack. They're enabling us to build a new generation of intelligent applications that can understand and interact with data in ways we've never seen before.
Whether you're building chatbots, recommendation engines, or any other AI-powered system, vector databases are an essential tool to have in your arsenal. And the learning doesn't stop here.
That's right. We encourage you to delve deeper into the resources we've mentioned in this episode. Experiment with open-source vector database projects, and stay curious about this rapidly evolving field.
This brings us to the end of our deep dive into the world of vector databases. We hope you found it informative and insightful.
Thanks for joining us on DemoHub Pod. Be sure to like, share, and subscribe for more explorations of the cutting edge of tech AI and data powered by AI. We'll see you in the next episode.